We are now looking at a question that was submitted by Miyelani Chauke. Miyelani, your question is beautiful. I'm not going to do the whole question because I'll tell you why. Some of the parts of your question we've dealt with in the previous two questions. So I'm going to deal with those issues in your question that did not pop up in the first two. I hope that's okay with you. If you go through your question, you can see that the stuff that they're asking you is actually exactly what they asked in the other question. So let's not waste time. The function given is h of x. It's a cubic. Notice that there's two variables. So to find those two variables, folks, you need 2 bits of information. Then there's a linear function. G of x is minus 12x. They also tell us that the turning point of h lies at point P and at point Q, which is 2 and 10. So that's 1 bit of information that we have that we can use here. Now the first part, and this is the beautiful part of this question, is they ask you to actually show that A is 3 over 2 and that B is 6. Okay, so show that A is 3 over 2 and that B is equal to 6. Now, remember what I said earlier. There's going to be something that's going to be very, very important. They give you information that repeat. So for the root of multiplicity 2, it was an x-intercept as well as a turning point. Now look at this. They tell me the turning point lies at that point. So there's your 2 bits of information. And this is what makes this question difficult, Miyelani, is if you don't interpret it the way I'm going to show you now, then you're going to be lost. You won't have enough information to work with in the question. Okay, so first of all, from point Q, so 9.1, from P, from point Q, we extract 2 bits of information. First of all, or it's h in this case, it's not function f, function h in the point 2 is 10. So that is just using the coordinate pair as given. They also told you, folks, that it's a turning point. If it's a turning point, we know that the derivative at that point is 0. So let's use that. And the derivative at the point 2 is indeed 0. So let's start with this one and see if it eases up a little bit of difficulty in this question. We start with the derivative information, and then we go and we use the point information. Okay, if I have the derivative, now look at how I crook. I differentiate this. I say minus 3 times x squared. Where there's an x, I leave a space. Plus 2ax plus b. And remember, the derivative of bx is just b. That derivative is 0. And everywhere where there was a bracket, I substitute my value of 2. It just saves time. So 3 times 4 is minus 12 plus 4a plus b is 0. And I can throw the 12 over. So I get 4a plus b, which is equal to 0. And I'm going to keep that in the wings. I'm going to come back to that later. Now let's use the information about the point 2 and 10. Remember, the x becomes a 2 and the result equals 10. So if I go here, I go to minus x cubed plus a times x plus b times x equals, what did they tell me? They told me 10. And in the space of x again, I go and I substitute my 2. So I get minus 8 plus, what is this, 2a. That's actually a square, so it's supposed to be 4a. Okay, let me just fix that. That's 4 times a plus 2 times b equals 10. I can throw the 8 over, and at the same time, no, let me do it a bit slower. Let's throw over the 8. So I get 4a plus 2b is equal to 18. And then from here, I can divide by 2. I get 2a plus b, which is equal to 9. Now, folks, this is my second equation. Now, if I now go and I subtract equation 1 minus equation 2, then I get 4a minus 2a is 2a. b minus b is indeed 0. And what did I do here? That is supposed to be a 12. I'm thinking far too fast for my own health. So that is a 12 minus 9, which leaves me with a 3. So a is equal to 3 over 2. Folks, don't be silly. Rather take your time and do it correctly than make these stupid mistakes that I'm making. You can see that some of my mistakes are really careless mistakes. You don't want to make these in an exam, because then a question which would have been easy becomes far more difficult, far too difficult for what it was intended to do. Okay, so now I've got the value of a. I'm going to go to equation number 2, and I'm going to put a in there, which is 3 over 2, plus the b value is 9. That cancels. 3 plus b, the 3 goes over, and b is 9 minus 3, which is indeed 6. Now, Miyelani, that question was difficult to start with. If you did not interpret the double information contained either in a root of multiplicity 2, which is a root and a derivative that's 0, or a turning point where they give you the coordinates of the turning point, and you also know at the turning point the gradient is 0. Don't forget that. That is the key to mastering a question like this. Then I'm going to skip your second part. Your second part just asks for an average gradient between 2 points. The third part again deals with concavity, and it asks show that the concavity changes at x equals to a half, which means your point of inflection. So minus b over 3a, x equals a half. You've solved the problem. Then they ask you to interpret the meaning of that answer. Now remember what I said, concavity changes through the point of inflection. The last one that I want to get to is the important one. It's the only question that's asking this. So now let's go back to what they gave us. They gave us the equation of a line, and they gave us the cubic, and we found those two values. The question, Yelani's question, part 9.5 says the following. Determine the value of x. So what is x? If x is negative, for which the tangent to the function h is parallel to the function g. Now that's important. The word parallel is operative there. That's why they gave us that equation. Now put your mind back to grade 9. When things are parallel, their gradients are equal. You also deal with that in analytical geometry, so it pops up over and over again. So what do I know? Because they parallel, I can say the derivative of h must equal minus 12. And what am I looking for? I'm looking for the negative x value that will do that. So I need to go back to my function, differentiate it, make it equal to minus 12, and that's my solution. So let's do that. Remember our function, our initial function needs a derivative. So it's minus 3x squared plus the 3x plus 6. Remember, all I'm doing is I'm taking this function here and I'm substituting a with 3 over 2 and b with 6, and I'm differentiating it. And that has got to be equal to minus 12. Now look again, everything is divisible by 3. So if I divide everything by minus 3, I get x squared minus x minus 2 is equal to 4. The 4 comes to the left. X squared minus x minus 6 is 0. I get a quadratic that factorizes beautifully. And remember, I'm looking for a negative answer. So x, 3, and 2. This is a minus, that is a plus, because minus 3 plus 2 gives the minus there, and the product of those two give you minus 6. So finally, we can answer the question, x equals to negative 2. This one is not applicable because we're looking for negative answers. So that was a tangent question. The question was, find the x value where the tangent to the curve of h is parallel to the linear function that they gave us. Okay, Mielani, I hope that that helped you. The other two questions that you gave me to work through was more or less a repeat of the ones that we've worked through already.